Hi, welcome back to my algebra class. For today, we will take up properties of exponents. For those of you who missed the first 3 lessons in algebra, search for my videos, Art Teaches Algebra, Lesson 1, Algebraic Expression, Art Teaches Algebra, Lesson 2, Addition of Algebraic Expressions, and Art Teaches Algebra, Lesson 3, Subtraction of Algebraic Expressions. The third operation on algebraic expressions is multiplication of algebraic expressions. But before we take up multiplication of algebraic expressions, we take the exponential notation and the properties of exponents, because we will need these properties of exponents in multiplying algebraic expressions and in simplifying algebraic expressions. The exponential notation is denoted by this notation, x to the power n. This is what is known as the exponential notation, where x here is called the base. X is the base. X is called the base of this exponential notation, and the power n here is called the exponent. N is called the exponent, or the power of x. The exponent n is usually a positive integer, but in examples later you will see that the exponent of the base can be negative exponents. And the base here is any number that is not equal to 0. And by expansion of this exponential notation, x to the power n, it means you multiply the base x by itself n times. Hence, x to the power n is equal to the product of x and itself. X is multiplied by itself n times. That is why at the right hand side of this equation we have n factors of x. Each of these is a factor of x, and there are n x factors of x to the power n. So x to the n by expansion is equal to the product of x by itself raised to the product of x with itself, and x is multiplied by itself n times. If you count the number of x's at the right hand side, you should have n factors of x. 1, 2, 3, up to n. We take an example of an exponential notation. Example, we have 3 to the power 2, or 3 raised to 2, or 3 squared. In this example, the base is 3, and the exponent is 2. And if you want to expand this exponential notation, 3 to the power 2 means that you multiply the base 3 by itself 2 times. So the number of times that you will multiply the base is equal to the exponent of the base. And the exponent of the base 3 is 2. That means you multiply the base 3 by itself 2 times or twice. Thus, we write 3 squared is equal to 3 multiplied by 3. We multiply 3 squared means we multiply 3 by itself 2 times. So at the right hand side, we have 2 factors of 3 squared. The factors of 3 squared are 3 and 3. And you multiply 3 multiplied by 3 equals 9. You can see that if you multiply the base by its exponent 2, the product is 3 multiplied by 2 is 6. And that is not equal to multiplying the base 3 by itself 2 times. Hence, do not multiply when you expand. When you find the product of x to the power n, we never multiply the base by the exponent. Because multiplying the base by the exponent, you will get x multiplied by n, or n multiplied by x. And n multiplied by x is not equal to, in general, is not equal to the product of x by itself n times. Again, when you multiply, when you expand an exponential notation, x to the n, such as 3 to the power 2, multiply the base x by itself according to the exponent of the base. Hence, 3 squared, we multiply 3 by itself 2 times or twice. Another example, here 5 to the m is raised to the power 3. That means the base of this exponential notation is 5m and the exponent is 3. And by definition of exponential notation, we multiply the base 5m by itself 3 times. Hence, the first factor is 5m. We multiply 5m by itself 3 times because the exponent of the base is 3. The first factor is 5m. Multiply it by another factor, which is again 5m. Now we have 2 factors. Both are equal to 5m. 1, 2, and 5m to the power 3 means we multiply the base 5m by itself 3 times. Thus, we need to multiply these 2 factors again by another 5m. Multiply by 5m. This is the expansion of 5m to the power 3. We multiply the base 5m by itself 3 times because the exponent of 5m is 3. Hence, we have 5m by 5m by 5m. And to find the product of this right-hand side, multiply the numerical coefficients. 5 by 5 is 25. 25 multiplied by 5 is 125. Now multiply the literal coefficient m, m, m. And you apply the property of exponential notation. We multiply m by itself 3 times, and it is the same as the exponential notation m to the power 3. M to the power 3 is equal to the product of m by m by m. Or m to the power 3 means you multiply m by itself 3 times. Thus m by m equals m to the power 3. Or after we have taken properties of exponents, you can apply one of the properties of exponents to find the product of m by m by m. And we will now start with the first property of exponent. We start with the first property of exponent. The first property of exponent says x to the power n multiplied by x to the power m is equal to x to the power n plus m. The given is at the left-hand side of this equation. The given are x to the power n and x to the power m. And these two exponential notations are multiplied. And the product is equal to x to the power n plus n. By this property, when you get the product of two exponential notations or two exponents, you copy the common base. The common base here is x, and you add the exponents of the base x. Copy the common base x, and the exponent of x is the sum of the exponents of the base from the left side. The exponent of the first base x is n, and the exponent of the second base x is m, and the sum is n plus m. This property applies only when you are multiplying two exponential notations with a common base, such as x to the n and x to the m. And to find the product of these two exponents, copy the common base, and the exponent of the common base, the exponent of the base in the product is the sum of the exponents of the exponential notations given. We take an example. We apply the first property of exponent. In number 1, we have y squared or y to the power 2 multiplied by y to the power negative 3. So in the second product, the exponent of y is negative, n is negative 3, multiplied by y. When the given has no exponent, such as y, it is understood that the exponent of that base is 1. When the exponent of the base is 1, such as y raised to 1, we omit 1 and we simply write, y. Thus, when you see a single variable such as y, it means that the exponent of that variable, such as y, is 1. So we obtain the product of these three factors, y squared, y to the negative 3, and y raised to 1. By this property, copy the common factor. Common factor is y. So this product is equal to y. And we add the exponents of the variables, the common variable y. In the first factor, the exponent of y is 2. And to 2, we add the exponent of the second factor, which is negative 3 plus negative 3. And to negative 3, we add the exponent of the third factor y. And we said that if a variable has no specified exponent, it's understood that the exponent of that variable, such as y, is 1. Hence, the exponent of y here is 1. So we add 1 to negative 3 plus 1. And simplify the exponent of y. We have 2. Positive times negative 3 is negative 3. The exponent now of y is 2. Positive times negative is negative 3 plus 1. And we get y to the power. Simplify further the exponent. We have 2 minus 3 plus 1. We have 2 plus 1 is 3. Minus 3 is 0. One of the properties of exponents is that if the base is raised to the power 0, then base raised to the power 0 such as y to the power 0 is 1. And this is true provided that the base y is not equal to 0. Again, one of the properties of exponent says that a base raised to the power 0 is 1, provided that the base is not equal to 0. We will write that property later on. For now, we take another example for the application of the first property of exponent. Suppose we have 3t cubed multiplied by negative 2t squared. We have 3t to the power 3 multiplied by negative 2t squared. To the literal coefficients, t cubed multiplied by t squared, we multiply the first property of exponent. But for the numerical coefficients of the factors 3 and negative 2, we simply multiply the numerical coefficients. You start by multiplying the numerical coefficients. 3 multiplied by negative 2 is negative 6. Now for the product of t cubed and t squared, apply this property of the first property of exponent. Copy the common base. The common base is t. We write t and add the exponents. Here the exponent of t is 3 plus, and to 3 we add the exponent of t here, which is 2. And simplify, we have negative 6 multiplied by t to the power 3 plus 2 is 5. Hence the product of 3t cubed and negative t squared equals negative 6t raised to 5. Again, when you are multiplying exponential notations, copy the common base and add the exponents. If the exponent of the base is 0, then the base raised to the power 0 is 1. But this is true only if the base is not equal to 0. And we will write this as one of the properties of exponent later on. And if you are multiplying monomials such as 3t cubed and negative t squared with numerical coefficients, start by multiplying the numerical coefficients such as 3 and negative 2. The product is negative 6. And to the literal coefficients, apply the first property of exponent. Copy the common base. The common base of t cubed and t squared is t. And add the exponents of t in the given factors. 3 here plus 2 here is 5. We are done with the first property of exponent. Again, the first property of exponent says if you multiply x to the n by x to the m, the product is x to the power n plus m. Here the base of x to the n is x and its exponent is n. In the second factor, the base is x and the exponent is m. When multiplying exponents, copy the common base is x, and add the exponents. Hence, the exponent of x of the product is the sum of n plus m, the sum of the exponents of the factors at the left-hand side. Now we rewrite the result we had earlier. The second property of exponent says that x to the power 0, x is the base, the exponent of x is 0, and x to the 0 by this second property is equal to 1. But there is a condition that says the base x must not be equal to 0. X is not equal to 0. Hence, this second property of exponent holds true only if the base is not 0. For any non-zero base x to the power 0, x to the 0, x is non-zero, x to the 0 is 1. Now what happens if the base x is equal to 0? If x equals 0, then x to the power 0, x to the power 0 is equal to 0 to the power 0. 0 to the power 0 is not 1. And 0 to the power 0 is not 0. 0 to the power 0 is what is known as indeterminate form, which means that the value of 0 to the power 0 cannot be determined. And this is one of the 7 indeterminate forms in mathematics. So if you get a result such as 0 to the power 0, you answer the product is indeterminate form. But if you have x to the power 0, it simplifies to 1, provided that the base x is not 0. We take an example for applying the first property of exponent and this second property of exponent. Example, p to the power 5, the base is p, the exponent is 5, and this is multiplied by negative 7, p to the power negative 5. Negative 7 is the numerical coefficient, p is the base, negative 5 is the exponent of p. Again, when you are multiplying monomials or exponents, you start with the numerical coefficients, multiply the numerical coefficients. The numerical coefficient of p raised to 5 is 1. There is no specific number in front of p, in the coefficient of p raised to 5. And we said that if there is no number in the coefficient of a literal coefficient, it's understood that the numerical coefficient of that literal coefficient is 1. So here it's understood that the numerical coefficient of p raised to 5 is 1. If the numerical coefficient is 1, you no longer write 1. So if we have 1 here as the numerical coefficient of p raised to 5, multiplied by negative 7, 1 multiplied by negative 7 is negative 7. For the product of p raised to 5 and p to the negative 5, use this property, first property of exponent. Copy the common base p. Common base p is p. Copy the common base. The common base is p. And add the exponents. Here, add the exponents of p. 5 plus negative 5 here. 5 plus negative 5. And simplify the right side. We have negative 7p to the power 5. Positive times negative is negative 5 equals negative 7p. 5 minus 5 is 0. Equals negative 7. Now, apply the second property of exponent that says a base to the power 0 is 1, provided that the base is not equal to 0. So we take p to the power 0 as 1, and we multiply it by negative 7. Negative 7 times p to the power 0 is 1 equals negative 7 multiplied by 1 is negative 7. Negative 7 provided p is not equal to 0. We do not know the base p, so we write p is not equal to 0, so that p to the power 0 is 1 by the second property of exponent, and we multiply 1 by negative 7 and we get negative 7 as the answer, provided that p is not equal to 0. We now continue with the third property of exponents. The third property of exponents, we have the product of xy to the power n. The base in this property is the product of xy. And the product of xy to the power n is equal to the product of x to the power n and y to the power n. So if you have a product of two variables raised to the same exponent, if you simplify that, you raise each variable to the exponent n and multiply. Again, xy to the power n equals x to the power n multiplied by y to the power n. We now apply this third property of exponents to these examples. In this example and this example, we will also apply the first property of exponent. In number 1, we have the product AB to the power 3. In this property, our x is a and our y is p. And by this third property of exponent, if ab to the power 3 means that you multiply a to the power 3 by b to the power 3. Hence, ab raised to 3 is equal to raise each variable to the exponent 3 and multiply. This is equal to a to the power 3 multiplied by b raised to 3, or b to the power 3. The variables a and b are raised to the same exponent 3 and they are multiplied. In number 2, we apply to each of these factors the third property of exponent, and after we apply the third property, we simplify further by using the first property of exponent. Hence, this is equal to, in this factor at the left side, 2x to the power 3, your x is 2, and your y is x. To raise 2x to the power 3, it means you raise 2 to the power 3 and raise x to the power 3 and multiply. We do that. 2x to the power 3 equals 2 raised to 3. 2 raised to 3 multiply by x to the power 3. Multiply by x to the power 3. This is just the simplified form of the first factor, 2x to the power 3. Again, we apply the third property of exponents to simplify 3x to the power 2. In our property number 3, x is 3, your y is x, and the exponent n is 2. To raise the product 3x to the power 2, raise 3 to 2 and x to 2 and multiply by the third property of exponent. So 3x to the power 2 equals 3 raised to 2. This is the product, the simplified form of the first factor. And to these factors we multiply by the simplified form of this second factor from the left side. 3x to the power 2 equals 3 raised to 2. Multiply this by 3 raised to 2. Multiply by x raised to 2 or x squared. And simplify this product to start with the numerical coefficients. 2 to the power 3 is 8. By definition of exponential notation, 2 to the power 3 means you multiply 2 by itself 3 times. So 2 to the power 3 is 2. Multiply by 2, multiply by 2. You multiply 2 by itself 3 times and you get 8. 2 to the power 3 is not equal to 2 multiplied by 3, which is 6. But the product is the simplified form of 2 to the power 3 is 8, not 6. Multiply by, we start with this numerical coefficient. 3 to the power 2 means you multiply 3 by itself 2 times because the exponent is 2. Hence 3 to the power 2 is equal to 3 multiplied by 3, which is 9. And multiply that by 2 to the power 3, which is 8. 8 multiplied by 9. Again, do not multiply the base by the exponent. 3 multiplied by 2 is 6. But the answer is 9. 3 to the power 2 is 9, not 6. Now we multiply the literal coefficients by the first property of exponents. Copy the common base. Common base is x. Multiply 8 by 9 by x. And by the first property of exponent, add the exponents. We have 3 here plus 2 here. 3 plus 2. And simplify. Multiply the numerical coefficients. 8 multiplied by 9 is 72. Multiply by x. And add the exponents. 3 plus 2 is 5. This is the simplified form of 2x raised to 3 multiplied by 3x squared. The product is 72x raised to 5. For our third example, consider negative mn raised to 5 multiplied by 2mn to the power 3 multiplied by n to the negative 3 and n to the negative 2. We start by applying the third property of exponents to the first factor and the second factor. The numerical coefficient of mn here is negative, but it's actually negative 1. And to raise negative mn to 5, you raise negative 1 to 5, m raised to 5, and multiply by n raised to 5. Multiply each of these factor, raise each of these factor to 5 by the third property of exponent. Thus, negative mn raised to 5 equals negative 1 raised to 5 multiplied by m raised to 5 multiplied by n raised to 5. And to this product, we multiply by the simplified form of 2mn to the power 3. Again, by the third property of exponent, you raise each variable, each factor of the product inside the quantity to the same exponent n. Thus, 2mn to the power 3 equals 2 raised to 3 multiplied by m raised to 3 multiplied by n raised to 3. We write that multiplied by 2 to the power 3 multiplied by n raised to 3 multiplied by n raised to 3. And this product we multiply by this factor m raised to negative 3 n raised to negative 2. Now we simplify beginning with the numerical coefficients. Negative 1 raised to 5 is negative. Negative 1 raised to 5 means you multiply negative 1 by itself 5 times. If you multiply negative 1 by itself 5 times, you will get negative or negative 1. We simplify 2 to the power 3. It means you multiply 2 by itself 3 times. The exponent 3 indicates the number of times that you have to multiply the base by itself. So 2 to the power 3 means you multiply the base 2 by itself 3 times. And we have done that. We get 2 to the power 3 equals 8. Multiplied by negative 1 is negative 8. Now we combine the literal coefficients, applying the first property of exponent. We start with the literal coefficients with m, common base is m, and by the first property of exponents, add the exponents of the common base m. Exponent here of m is 5 plus exponent here of m is 3 plus the exponent of m here is negative 3. Now we combine the literal coefficients with common base of n. n5 multiplied by n cubed multiplied by n to the negative 2. And we apply the first property of exponent. Copy the common base n. And add the exponents of n. Exponent of n here is 5. Exponent of n here is 3. And, again, to multiply n raised to 5 by n cubed by n to the negative 2 by the first property of exponent, copy the common base n and add the exponents. Here the exponent of n is 5. To 5 we add plus the exponent of n here is 3. And to 3 we add plus the exponent of the last factor n to the negative 2. The exponent is negative 2. And we simplify further, negative 8. Multiply by m to the power add 5 plus 3 is 8. Positive times negative is negative 3. So we get 5 plus 3 minus 3 is 5. M raised to 5 multiplied by n to the power 5 plus 3 is 8. Positive times negative 2 is negative 2. So this is 5 plus 3 minus 2 is 6. That's the product of the given minus mm raised to 5 multiplied by 2 mn raised to 3 multiplied by m to the negative 3 and by n to the negative 2. In the next property of exponent, an exponent of x is raised to another exponent. For the whole exponential notation, the base is x to the n. But this base has a base of x with an exponent of n. And x to the n is raised to an exponent m. And this property says that x to the n raised to m is equal to x raised to n multiplied by m. The exponents n and m are multiplied. Hence, x to the n raised to m is equal to x to the power n multiplied by m. We apply this fourth property of exponent together with these other properties of exponents. Consider number 1. We have a raised to 5 to the power negative 2. In this example 1, your x is a, n is 5, m is negative 2. And to simplify this by the fourth property of exponent, simply multiply the exponents. Multiply 5 and negative 2, and that is the new exponent of a. Hence, a raised to 5 to the power negative 2 equals a. A to the power or exponent of a is the product of 5 and negative 2, which is 10, negative 10. Again, to simplify a raised to negative 5 to the power negative 2, copy the base a, and the exponent of a is the product of the exponents 5 and negative 2, which is negative 10. In number 2, we simplify this product, which is a product of these three factors. For simplifying the first factor, we first apply the third property of exponent. And then we apply the fourth property of exponent. And to simplify further, we apply the first property of exponent. We have p squared times q to the negative 3 raised to 2 by the third property of exponent. You raise p squared to 2, p squared to the power 2, multiplied by q to the negative 3 raised to 2, q to the negative 3 raised to 2. We apply the same third property of exponent to simplify this second factor of the given, negative 2 multiplied by p to the negative 1 multiplied by q squared raised to the power 3. By the third property, we raise negative 2 to 3 multiplied by p to the negative 1 raised to 3 multiplied by q squared raised to 3. We write negative 2 raised to 3 multiplied by p to the negative 1 raised to 3 multiplied by q squared raised to 3 and we also apply the third property of exponent to the last factor of the given. To simplify 3p q squared raised to 2, we apply this third property of exponent. We raise 3p and q squared to the power 2 and we multiply. Hence 3p q squared raised to 2 is equal to 3 raised to 2 or 3 squared multiplied by p raised to 2 or p squared multiplied by q squared raised to 2. Q squared raised to 2. To simplify this product, start with the numerical coefficients. Negative, this is actually negative 1 multiplied by 2. And apply the third property of exponent. Raise negative 1 to 3. Negative 1 to 3 means you multiply negative 1 by itself 3 times. And negative 1 raised to 3 is negative. Multiply by 2 to the power 3 means you multiply 2 by itself 3 times. And we get 8. Multiplied by 3 to the power 2, which is equal to 3 multiplied by 3, and it's equal to 9. Now we simplify the literal coefficients by now applying the fourth property of exponent. P squared raised to 2 by the fourth property of exponent means you multiply the exponents. So p squared raised to 2 is p, and the exponent of p by the fourth property of exponents. Multiply the exponents. Multiply the exponents of p. 2 and 2 is 4. Multiply by q. Again by this property of exponents, multiply negative 3 by 2, that's the exponent of q, negative 6. We have simplified negative 2 by 3, it's equal to negative 8. Again by the fourth property of exponent, p negative 1 to the power 3 is equal to p. The exponent of p is the product of the exponents negative 3, negative 1 and 3, or negative 3. And by this property again, the cube of q squared equals q. The exponent of q is the product of the exponents 2 and 3, 6. We have simplified 3 squared and we get 9. Multiply by p squared. And the square of q squared by this property is equal to q, and the exponent of q is 2 by 2, 4. Now to combine the literal coefficients with a common base of p and common base of q, apply the first property of exponent. Multiply the numerical coefficients. We have negative 8 by 9 is 72. We start with a common base of p. Common base is p. Add the exponents of p by the first property of exponents. We have 4 plus negative 3. Or you may write 4 minus 3. And plus 2 here, the exponent of p plus 2 multiplied by, now we simplify the literal coefficients with common base of q. Q, exponent here is negative 6 multiplied by q to the power 6. Exponent is positive 6, we write plus 6. And the last factor, q raised to 4. Exponent of q is 4. We write plus 4. And we simplify negative 72 multiplied by p. Find the sum. 4 plus times negative 3 is negative 3. Hence we get 4 minus 3 plus 2 is 3. Multiplied by q. The exponent of q, negative 6 plus 6 is 0. Plus 4 is 4. Hence, this is the simplified form of the given product. And we have simplified that by using the properties of exponents. In many problems in mathematics, we would like to remove negative exponents from the final answer. Most answers look better if we do not have negative exponents in the final answer. And the next property of exponent can be very useful in removing negative exponents from the final answer. The P property of exponent says that x raised to negative n, the exponent of x here is negative, indicated by negative n. And x to the negative n by this property is equal to 1 over x to the power n. The exponent of x here now in the denominator is positive n. And we have 1 in the numerator because the numerical coefficient of x to the negative n is understood to be positive 1. So if you want to remove a negative exponent, if you have negative exponent in the numerator, you bring it down to the denominator and you take the opposite sign of the exponent. If you want to, you can also bring x to the n to the numerator and you will go back to the left hand side of this equation. If you bring x to the n to the numerator, take the opposite sign of positive n. Its opposite sign is negative, and you have x to the negative n in the numerator. We apply this property and other properties of exponents to simplify the following problems. Number 1, 5x to the negative 3. We want to remove negative 3 from here, from the exponent of x. And to do that, we apply this property, P property of exponent. The numerical coefficient 5 will remain in the numerator. And x to the negative 3 we bring down to the denominator of 5. We write x to the power 3 as denominator of 5. When you bring x to the negative 3 to the denominator of 5, you take its opposite sign by this property of exponent. Hence, 5 multiplied by x to the negative 3 equals 5 over, bring this to the denominator, take the opposite sign of negative 3. You get x to the power 3. Number 2, we simplify 3xy to the negative 1 raised to the power negative 2. We apply the third property first to this given. By the third property of exponent, you raise each factor 3xy to the negative 1, raise each of them to the power negative 2. And we get 3 raised to negative 2 y to the power negative 2, x raised to negative 2, and y raised to negative 1, y raised to negative 1 to the power negative 2. And we simplify. Again, we remove the negative exponents by applying this property. Those with negative exponents, we bring them to the denominator by taking the opposite sign of the exponent of the base. 3 to the negative 2, we bring this down to the denominator and we take the opposite sign of negative 2. And we get 3 to the power 2. Multiply by x to the negative 2, you bring this down to the denominator, but take the opposite sign of the exponent of x. And we write x, opposite sign of negative 2 is positive 2 or 2. And we simplify y to the negative 1 raised to negative 2 by applying the fourth property of exponent. Multiply the exponents. You have negative 1 multiplied by negative 2 is positive 2. Hence, y to the negative 1 raised to negative 2 is y to the power negative 1 multiplied by negative 1 is 2. And we simplify 3 squared. We get y squared in the numerator over 3 squared is 9. 9 multiplied by x squared. And that's the simplified form of 3xy raised to negative 1 raised to negative 2. Consider number 3. We simplify each factor first by applying the third property of exponent. For the first factor, raise negative 2 to the negative 2, x squared to negative 2, y cubed raised to negative 2. We do that, negative 2 raised to negative 2. x squared raised to negative 2 and y cubed multiplied by y cubed raised to negative 2. For this factor, we apply again the third property of exponent. Raise 3, x to the negative 3, and y raise each of these to the exponent 5. We have 3 raised to 5. X to the negative 3 raised to 5 and 5 and y raised to 5. Now we simplify. We write negative 2 to the negative 2. To simplify, x squared raised to negative 2, apply the fourth property of exponent. So x squared raised to negative 2 is x to the power, multiply the exponents 2 by negative 2 is negative 4. Multiply by y, by this property, y is raised to 3 multiplied by negative 2 is negative 6. And 3 raised to 5 means you multiply 3 raised to 5 means we multiply 3 by itself 5 times. 1, 2, 3, 4, 5. And we multiply, 3 by 3 is 9. 3 by 3 is 9. And multiply by the last 3. 9 by 9 is 81. And multiply by 3. We get 3 by 1 is 3. And 3 by 8 is 24. Hence 3 to raise to 5 is 243. Multiply by 243. Simplify x to raise to negative 3 raised to the power 5. By the fourth property of exponent, you get x to the power, multiply the exponents negative 3 by 5, negative 15. Multiplied by y raised to 5. And we simplify this further. We get, start with, now we write those factors with negative coefficients. We write them in the denominator by applying the P property of exponents. Those factors with positive exponents will remain in the numerator. But first we combine the similar literal coefficients, those literal coefficients with common base of x. We retain negative 2 to the power negative 2. Multiply by x, common base is x. And we apply the first property of exponent. Copy the common base and add the exponents. Negative 4 plus negative 15, or negative 4 minus 15 is negative 19. Multiply by the literal coefficients with common base of y. Copy the common base by the first property of exponent, y. Add the exponents of y, negative 6 here, and positive 5 here. And you get negative 6 plus 5 is negative 1. Multiply by this numerical coefficient 2, 4, 3. Now we apply the P property of exponent. Only 243 will remain in the numerator because these three factors have negative exponents, and we will bring them down to the denominator, and we will take the opposite sign of their exponents. We get 243. Bring this in the denominator. Take the opposite sign of its exponent, 2. We bring this in the denominator, take the opposite sign of the exponent of x. We get x raised to 19. Take y raised to negative 1 to the denominator, take the opposite sign of the exponent of y. Y raised to 1. Or 243. We simplify negative 2 square by applying the third property of exponent. That means you square negative 1, multiply by the square of 2. And the square of negative 1 is positive 1. Multiply by the square of 2. 1 multiplied by the square of 2, 4 is 4. Multiply by x to the power 19. And again, when the exponent is 1, we do not write anymore the exponent 1. We omit 1 and we simply write y. And this is the simplified form of the given in number 3. So far we have taken 5 properties of exponents. The first property of exponent says if you are multiplying exponential notations with common base x, copy the common base and add the exponents of the common base. Add the exponents. Second property says if you have a base to the power 0, it simplifies to 1, provided that the base is not equal to 0. In the third property, the base is a product of 2 variables, and their product is raised to an exponent n. And this product x to the n, xy raised to n is equal to the product of x raised to n and y raised to n. In the fourth property, the base is raised to an exponent, and this base is raised to another exponent. And by this property, x to the n raised to m is equal to x raised to the product of the exponents n and m. In the fifth property, which we can use for removing negative exponents in the final answer. If you want to remove the negative exponent of x, bring x to the negative n to the denominator, but you take the opposite sign of the exponent of x. Now we will take the sixth property of exponent. And the sixth property is for the quotient of two exponential notations. This property says x to the n over or divided by x to the m is equal to the common base x. Common base in the numerator and denominator is x. And the exponent of x is the difference of the exponents of x in the numerator and denominator. When you get the difference of the exponents of x in the numerator and denominator, always start with the exponent of x in the numerator. And from the exponent of x in the numerator, you subtract the exponent of x, m, in the denominator. We apply this property to these examples. For number 2, we apply the other properties of exponents in addition to this 6th property. Number 1, simplify t raised to 5 over t to the power 7. The common base in this example is p. We get p, and by the 6th property, we get the difference of the exponents. We get the difference of the exponents 5 and 7. We write first 5, the exponent of t in the numerator. And from 5, we subtract the exponent of t in the denominator, minus 7. We simplify t to the power 5 minus 7 is negative 2. And from now on, we will always remove negative exponent from the final answer. And we want to have a positive exponent for t, so we apply the P property of exponent. You bring this down to the denominator, and we take the opposite sign of the exponent. Hence, t to the negative 2 equals 1. Numerator is 1 because the numerical coefficient of t to the negative 2, numerical coefficient of t to the negative 2 is positive 1. And we bring this in the denominator, we take the opposite sign of negative 2. We write t to the power 2. And this is the simplified form of example 1. We simplify example 2. We start by simplifying the numerator. To simplify the numerator, we apply the 3rd property of exponent, and then the 4th property of exponent, and then the 6th property of exponents. We start with the numerator by the 3rd property of exponent, 3x squared y to the negative 1 to the power 3 is equal to, you raise to the power 3, 2x squared and y raised to negative 1. So this numerator is equal to 2 to the power 3 multiplied by x squared to the power 3, x squared to the power 3 multiplied by y raised to negative 1 raised to the power 3 divide by the denominator 4, x raised to 7, y to the negative 6. And we simplify the numerator. 2 to the power 3 means you multiply 2 by itself 3 times. So that's 2 multiplied by 2 multiplied by 2 is equal to 8. 8 multiplied by x squared raised to 3 by the 4th property is equal to x to the power 2 multiplied by 3. Multiply the exponents. X squared raised to 3 is x to the power 6. Again, apply the 4th property of exponent. Y raised to negative 1 to the power 3 is y raised to Negative 1 multiplied by 3 is negative 3. Divide by 4, x raised to 7, y to the negative 6 equals, simplify the numerical coefficients if they can be simplified. Here 8 over 4 can be simplified as 2. 8 divided by 4 is 2. Now to simplify this 2, x raised to 6 divided by x to the power 7. Apply now the 6 property of exponent. Copy the common base x and get the difference of the exponents. Beginning with the exponent of x in the numerator minus the exponent of x in the denominator. We have 6 minus 7. And again, apply the 6 property of exponent to simplify y to the negative 3 over y to the negative 6. Copy the common base y. And get the difference of the exponents of y. Starting with the exponent of y in the numerator, negative 3, minus the exponent of y in the denominator, negative 6, minus negative 6. And simplify, we get 2 multiplied by x raised to 6 minus 7 is negative 1. Multiplied by y raised to negative 3. Negative times negative is positive, 6. So the exponent is negative 3 plus 6 or positive 3. But we have a negative exponent for x and we do not want negative exponent in the final answer. So we bring this x down to the denominator by applying this P property of exponent. And we get 2y cubed. We write x down to the denominator and we take the opposite sign of negative 1 will be positive 1. So the exponent of x is 1. But we do not write 1 anymore and we simply write x. And this is that's the simplified form of the given quotient in number 2. We are down to the last property of exponent. In this property, we have a quotient of two variables, x and y, raised to an exponent. And by this property, x over y divided by n is equal to x to the power n over y to the power n. The numerator and denominator is raised to the same exponent n. And we get the quotient of x to the n and y to the n. For example number 1, we apply this property of exponent to simplify this example 2. We apply this property of exponent and other properties of exponents. In number 1, we have m over n to the power 5. In this property, x is m or y is n. And the exponent n is 5. By this property of exponent, you raise the numerator and the denominator to the same exponent 5. Thus, m divided by n raised to 5 is equal to, raise the numerator to 5 and divide by divide by raise the denominator, the variable in the denominator to 5. In number 2, we simplify the first factor using the 7th property of exponent. For the second factor, we simplify it by using the third property of exponent. We start with the first factor by this property is equal to the numerator raised to 4 divided by the denominator raised to the same exponent 4. So the first factor is equal to the numerator a squared b cubed raised to 4 divided by denominator raised to 4. A to the negative 1 times b to the negative 2 raised to 4. And multiply by ab cubed raised to negative 1. We simplify this numerator by the third property and the denominator by the third property, and also this factor by the third property. For the numerator, by the third property of exponent, you raise a squared and b cubed raised to 4. We have a squared raised to 4 multiplied by b cubed raised to 4. Apply the same third property to the denominator, a to the negative 1 raised to 4. A to the negative 1 raised to 4 multiplied by b to the negative 2 raised to 4. B to the negative 2 raised to 4. And apply the same property, third property of exponent, to simplify this factor. Raise a to the negative 1 and multiply by b cubed raised to negative 1. We write a raised to negative 1 multiply by b cubed a raised to negative 1 multiplied by b cubed raised to negative 1. To simplify each factor in the numerator, we now apply the fourth property of exponent. Multiply the exponents 2 and 4. Multiply the exponents 3 and 4. Negative 1 multiplied by 4. Negative 2 multiplied by 4. And 3 multiplied by negative 1. We start from the numerator. A squared raised to 4 is a to the power 2 by 4 is 8. A raised to 8 multiplied by b raised to 3 multiplied by 4 is 12. Over a raised to negative 1 multiplied by 4 is negative 4. A raised to negative 4 multiplied by b raised to negative 2 by 4 is negative 8. B raised to negative 8 multiplied by a to the negative 1, b multiplied by b raised to 3 times negative 1 is negative 3. And we simplify this factor by now applying the sixth property of exponent. We have a common base A. And this property says we get the difference of the exponents. We have 8 minus 4. 8 minus negative 4 multiplied by b. B raised to 12 divide b to the negative 8. Apply the sixth property of exponent. Common base is b. Common base is b, and we get the difference of the exponents, 12 minus negative 8. 12 minus 8. And we multiply this by a raised to negative 1. A raised to negative 1 and multiplied by b to the negative 3. We simplify. Negative and negative is positive 4. Plus 8 is 12. A raised to 12. Multiplied by b. This is 12. 12 minus 8. 12 minus negative 8. Common base is b, and we get the difference of the exponents, 12 minus 8. And negative times negative is 8 plus 12 is 20. Multiplied by a raised to negative 1 multiplied by b raised to negative 3 equals. Now combine the terms with common base, the factors with common base a. Apply the first property of exponent. Common base is a. And the first property of exponent says we add the exponents. Hence, we have 12 plus negative 1, or 12 minus 1 is 11. And combine the factors with common base of b. Copy the common base. And add the exponents by the first property of exponent. 20 plus negative 3, or 20 minus 3 is 17. And this is the simplified form of the given in example 2. And then apply the properties of exponents. In the next lesson, we will apply these properties of exponents in the third operation for operation on algebraic expressions, the multiplication of algebraic expressions. If you have any questions about the lesson today, you ask your question in the comments below. And do not forget to subscribe to my YouTube channel, Algebra-Lesson. Thank you.